We're going to finish up today with a chain rule, so we're going to do some more practice with the chain rule, and we're also going to look at some parametrics. And specifically, our goals are to practice the chain rule and to explore derivatives of parametric equations involving the chain rule. So, last class we left off with this example. I left you with it, and it says find the slope of the line tangent to the curve y equals sine x to the fifth power at the point where x equals pi over 3. Then after you find the slope at that particular x value, I want you to find the equation of that tangent line. So what I've left for you right here are the steps you need in order to write equations of tangent lines. We've already written this down once in our notes, so you should have it in your notes. If you've already got this problem done, great. Check to see if other people in your group do. If they don't, help them out. If they do, you guys don't have to press pause, and you can just keep the video playing and look at the answer. If you're not done, press pause right now, finish the problem, then you can check the answer. Alright, so here's the answer to that problem. The first thing you want to do is figure out what the sine of pi over 3 is, because you're going to have to use that several times in this problem. So when we take the derivative, we have to use the chain rule. Remember that fifth power is on the outside, so that's our outside function. So the derivative is 5 times sine of x to the fourth power, and then we have to take the derivative of the inner function, which is sine x, so we get cosine x. So this is our derivative. We've got to evaluate that at pi over 3, so we need to plug in a pi over 3 everywhere we see an x, and when we do that, we get this, and that simplifies to 45 over 32. You should be able to do all of this without a calculator. If you're reaching for your calculator, put it away, force yourself to do this without a calculator. When you get this 45 over 32, that's your slope. So you've gotten the slope. Next thing you need is an x and a y. So they give you the x. If x is pi over 3, we just need to plug that x value all the way back into our original equation to get the y value. And the y value here is 9 square roots of 3 over 32. Remember, when you write the equation of your line, always write the equation in point slope form. So that's y minus y sub 1 equals m times the quantity x minus x sub 1. Alright, so make sure you're using this form, because when you get your x, you just plug that into your x. When you've got your y, you plug that into your y. And when you get your slope, you plug that in right here to your slope. So this is our final answer. Check that with your group. Make sure everybody agrees. Right, here's a parametric equation. So what I've given you is a function in terms of t, and here's x defined in terms of t and y defined in terms of t. What I need you guys to do is figure out what dy dx is given these two components. So press pause and think about that with your group. If you need a hint, restart the video and I'll just give you a hint. I won't give you the answer yet. So here's the hint. What I want you to think about is what dy means. dy is delta y. dx is delta x. Remember, the slope is the change in y over the change in x. Well, I have an x and a y here. And remember, when we take the derivative, we're getting the slope. That's the change. So if we figure out dy over dt here, that's going to help us. And if we figure out dx over dt, that's also going to help us. Alright, so remember, you go back to your original meaning of slope. If you calculate dy over dt and dx over dt, what you've actually calculated is the change in rise over the change in run. Also, you see all these d's in derivatives? The d's represent the deltas that we've used in the past. So the reason we've got d's is because of the delta. Alright, there's a hint. See if you can figure out the rest of the problem. When you're ready, press start. So go ahead, pause now. When you get your problem done, press start for the solution. Alright, here's the solution. You can see some notes that I have from the other class when we worked this out. We've got our derivatives here. We take and we divide them. We end up with our dy dx. So when we get our actual derivatives, you just want to divide them. And it's okay to simplify. In fact, this is a really nice way to simplify and leave your answer the opposite of cotangent t. And that's the derivative. We can figure out the slope of the tangent to the curve defined in terms of x and y given any t value, and usually t is in terms of time. All right, let's look at some more problems. All right, what I want you to do for this particular problem is find the tangent to the right-hand hyperbola branch defined parametrically by x equals secant t and y equals tangent t when t is between negative pi over 2 and pi over 2 at the particular point square root of 2 comma 1 when t equals pi over 4. All right, that's a lot. Okay, so what we need to do is figure out what exactly we're supposed to do. Now they're talking about the right-hand hyperbola branch. If you guys remember hyperbolas, these are conic sections. You did these in Algebra 2 Trig. And hyperbolas usually have two sides, and they've got asymptotes that go like this. And if you remember, the way you figure out these asymptotes is you've got to figure out a center, and then you've got to draw a rectangle around that center, and then you've got to connect the corners of the rectangles to get your asymptotes. So we're really going to only focus on the right-hand branch of the hyperbola, but really, you know what? You don't need to know any of this in order to do this problem, because what this problem is asking you for is the tangent to the right-hand hyperbola branch. And what they mean by tangent is the tangent line. So we need our final answer to be the equation of a line. And usually in the calculus, we're going to write equations of line in point-slope form. So we're going to have y minus y sub 1 equals m times the quantity x minus x sub 1. So we need to figure out what our slope is, our y value, and our x value. So we need a point to get our x and a y and our slope. All right, so go ahead, work with your group, press pause. When you've got your answers, start up the video again. Let's take a look at the solution. So when we do this, we're already given the point. So we have our x sub 1 and our y sub 1, which is nice. What that means is the only thing left we have to find is the slope. So we have to take the derivative of the x, the derivative of the y, and make sure we do dy dt divided by dx dt. When we simplify that, we end up with cosecant of t, and that needs to be evaluated when t equals pi over 4. And when we do that, we get the square root of 2. That is our slope. So we plug in our y sub 1, our x sub 1, and our slope, and we have the equation of our line. So check with your group, make sure everybody agrees, make sure you've all got that, and then I want you guys to start doing some more chain rule practice problems. So you've got the worksheet that you have, or you can also work on these problems, or both. So here are some problems. There are 7 problems here. The answers are following, so if you press pause now, you can check your answers in a few minutes. I hope this helped. I'll be around on Friday, so come see me if you need any help. All right, here are the answers to those 7 problems. Hopefully you can see them with the resolution on the video. If you can't, use your calculator to take the derivatives and make sure they match up. They might not look exactly the way mine do. Or you can check the notes online and the answers will be posted there as well. All right, see you later. Have a good one.